Good evening, Internet. I am Matt Buyak, and this is the first in a series of 3 videos in which I'll develop a solution for working with prime numbers. So in a previous video, I showed a solution to Project Euler problem number 7. And this problem asks us to find the 10,001st prime number. And in that video, you may recall I mentioned some of the techniques that we were using might not be considered to be software design best practices. Now, that doesn't necessarily mean that they were bad or wrong. Depending on the circumstances, sometimes it might be more important to move quickly than to make sure you have the perfect design. For example, if you're doing competitive programming, or if you're working on a prototype or proof of concept, or maybe even on a job interview, or in our case, solving programming puzzles. There might be other things more important than the best design. But we're going to be doing a lot of work with prime numbers. Many of the Project Euler questions involve prime numbers. And so we really want to have a solid solution for doing that work. And so the next question is, where do we put this code? I could just shove it into the problem 10 directory. That's the next problem involving prime numbers. But then the next problem after that, we would have to copy our prime number code to the new directory. And then the next problem involving primes after that, we would have to do the same. And you can see that this very quickly becomes tedious and error-prone and doesn't scale very well. And so we need to introduce the idea of a library. So a software library is just a collection of code that exists independent of any particular software program. And then instead of including the whole source code into your program, you can just connect to the library and get access to that functionality in that way. In fact, you don't even need to have the source code at all to make use of the library. Often, in a professional software engineering environment, you may not. The vendor may specifically withhold that source code if they think that it contains trade secrets or proprietary information that they'd rather not reveal. So there are generally 2 kinds of libraries that you should be aware of. The first is a static library, and that's the kind that we're going to be creating. So in a static library, the compiled code from the library is included directly into your project. So that is, rather than including the source code and then compiling that with your project, the source code has already been compiled, and you're just including the raw code into your program. Now, the disadvantage of that approach is that it means that every program in the system that uses that library has a separate copy of that library. So you can see how that would be potentially wasteful. On the other hand, if your library is small or it's used by a small number of programs, then maybe it's not worth fretting over. The other kind of library is a dynamic library. And the idea behind dynamic libraries is that there's a single copy of the library that's loaded into memory by your operating system. And then that library is used by every program in the system that uses that library. Now, the downside of this approach is that it makes your code a little bit less portable. If you should try to run your program on a system that doesn't have the required library or has the wrong version of the library, it might crash or otherwise misbehave. So let's get into it. With all that background out of the way, here we have our solution from problem 7 you might recognize. But before we look at that, let's create a few new directories. Create one common. That's where we'll put our library. and then one tests. That's where we'll put our tests. Now, one thing to be aware of with a static library is that there's no way to run it by itself. It doesn't have a main entry point the way a normal program does. And so if you want to exercise the code in that library, you need to make some kind of test harness to do so. And actually, let me just copy from our template directory our main.cpp into our test directory. And we'll just call that primes test.cpp. Before we take a look at that, let's put together our library. And so we'll call that primes.cpp. And just as our first pass, we're not going to put the actual primes functionality in here. We just want to test to make sure that we can build and link our library and that everything is working as expected. So we're just going to make a function here. It just prints success. Now you might remember this stdio from our problem solutions. That just gives us access to this printf function. But this syntax here, including primes.h, is new. So the angle brackets here basically say, look in the usual place where the libraries are kept. But these quotes say, look in the usual place for header files for this project. And that might be the current directory, or it might be an adjacent directory. There are arguments when you're doing your build to indicate where to look for each of these. And in our case, our primes.h is just going to be in the same directory. And so we just need to declare our single method there. And then we're going to have our makefile. And so we'll say lib numtheory. And that's going to depend on primes.o. I'll explain what that is in just one moment. And I can never remember the syntax for building a static library. One minor mistake here. Go. So I can never remember the syntax, so I usually have to look it up. And so this is it right here. Uses this utility AR. It's not really important that you know what these mean. I believe the C is for create. You can look this up if you're interested, but mostly we just need to copy and paste this into our makefile. So we're going to say AR RCS lib numtheory.a. You'll note that I'm calling this numtheory rather than say libprimes. In anticipation of adding more functionality to this library. As we continue to solve more problems, prime numbers are probably not the only thing we're going to need common code for. And so we'll add those to this library also as they come up. And so then we'll say primes.o. And so this .o file, we haven't encountered this yet, I believe. But that's just the raw code that can be executed by your machine. So your computer doesn't know how to execute C and C++. It runs a particular instruction set that depends on the processor that you've got in your machine. And so when we build our program, that's what we're doing, is we're taking the C and C++ and turning it into something that your computer can understand. And so this primes.o is just our library code in that form where our computer can understand it, but it hasn't yet been added to a library. And that's what this command does. So then we'll also need a line to create our primes.o, and that's just going to depend on primes.cpp. Yes. And just like with our other make files, we're going to do g++ primes.cpp-o primes.o. But there are a few extra arguments that we're going to need. In particular, because we're not building an executable, we're just building this object file, we need to say g++-c. And so now we should be able to go to our common directory, make, and see that our library has been constructed there. So now if we go over to our tests directory, let's create a make file there. Let me actually, just to simplify things slightly, we'll just say copy template make file and copy that over to our test directory. It's not exactly what we need, but it's close enough that it gives us a starting point. Okay, so our program here is not going to be called solver. We're going to call it primes test, and that's going to depend on primes test.cpp, and the output is going to be primes test. Also here, primes test.cpp. So you'll notice the convention often is to call our main the file containing our main entry point main, but that's not a requirement. And in this case, we anticipate in the future that we'll be adding multiple tests in here. Most likely, each piece of code that we're adding to our libnumtheory library, we'll want to have a test for that. And so we don't want to have just one main.cpp. We probably want to have a separate CPP file for each test that we're going to have in this directory. And that's why I named it primes test rather than main.cpp. So now if I try to compile this, you'll notice it doesn't work. Well, it definitely won't work from there. Let me go to the correct directory. I didn't actually make any changes to our primes test here. So here we need to be including primes.h, and we need to be calling test. There we go. Okay, so it doesn't know where to find primes.h. So as I mentioned earlier, this usually means, this basically tells the compiler, look in the usual place for header files for this project. But we haven't told it where that is, and so it's just looking in the current directory. So if we go back to our make file here, we can actually tell it where to look for that header file. And we can also tell it where to look for our library. We'll also have to do that. So that's going to be under common, and we'll say -l common -o primes. But now we also have to specifically link our library. So there are multiple steps here in the build process. And I haven't really delved into this in depth in the past. But basically, there are three phases. You've got your compilation phase, which is where your source code is turned into this object code, the .o files. And then you have the linking phase, where the .o files are all connected together. And then you have the execution phase, where you're running your program. And so previously, the linking phase and the compilation phase were all just done in a single step because we only had a single source file. But now our build process is starting to get a little more complicated. And so we need to say -l num theory, and this tells our linker to link the num theory library that we've built. So you'll notice that I left off the .a and also the lib at the beginning. So this is why there's a convention to name your libraries starting with lib, because if you do so, you can just do this and it knows what you're talking about. Oh, minor typo here. Okay, and we have success. So we've built our library, we've linked it with our test program. We verified that it's working as intended. Great. So now we want to pull in our code from problem 7 here. So let's just grab this code here. And we're just gonna we'll have a function here, get prime which will get us the nth prime. So we don't need our like placeholder test there anymore. We need to change our primes.h. So that instead we have get prime, and we'll need now in this file studint.h, and also from our problem 7 we will need our sieve. Okay, so you can see that in the original code, we've just hard-coded this this target prime value, and so we really want to replace target prime with n, and we don't need that here. We also don't need to print out our result. Instead, we're going to be returning our result. So we'll just say return I. We also don't need to keep track of the largest known prime, so we can remove that. Now you'll notice that if we get to the end of our function here, that means we didn't find our prime, that our sieve wasn't big enough. And so we might just print out error, sieve wasn't big enough. So obviously this is less than ideal, but we can deal with this when we get to cleaning up and improving this code. For now, this will be just fine as a placeholder. Yes, so we'll also need to include string.h. Okay, so we've rebuilt our library. Now, switch over to our test. And now we'll want to say printf 10,000 first prime is, and then we can just say get prime 10,001. And if you recall from our problem 7 video, we can go back to the archive and check. Oh, I don't appear to be logged in. In any case, we can go to our problem 7 directory, run our solver, and see that that does indeed match our expectations. Now, for the observant among you, you might recognize that I haven't actually made any improvements to our solution. I kind of just moved code around without actually improving it at all, and that would be a fair assessment. So in the next video in this 3-part series, I'm going to talk about object-oriented programming, and we're going to use the techniques of object-oriented programming to actually start making improvements to our primes code. And then in the video after that, we'll continue our discussion on object-oriented programming and start to add some features that we didn't even need for problem 7, but will definitely be helpful in the future. So if any of that sounds interesting to you, then I would encourage you to keep an eye out for those videos.